Mean absolute deviation. And so this is an extension lesson. And we often refer to this as MAD, which is the average distance between each data value of a set and the mean. So think about that for a moment. The average distance, we think of mean as average, absolute, I think absolute value, and deviation, I think about that distance between the data set and the mean. So we have to find the average first and then find the average distance. So what does that look like? Well, let's look at a set of numbers, a set of data values. I have 58, 88, 40, 60, 72, 66, 80, and 48. So step one, I need to find the mean. And again, that is adding up all the data values and dividing by the total number of values we have. So that would be 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48 divided by 1, 2, 3, 4, 5, 6, 7, 8. And so we should get a total of 512 and divide that by 8. And we should get a mean of 64. That means the average of all those values. So step 2 requires us to find the absolute value which we know look like brackets, of the differences between each value in the mean. So for example, my first data value is 58. The difference means subtract and the mean. So let's take the data value minus the mean and take that absolute value. That gives me an absolute value of -6, which I know is 6. So try that for the rest of the data values. So you should get these answers, and so that's step 2. Step 3, the final step, is to find the average of the absolute values. So that's step 3. So I just have to add all these up. We have 6 plus 24 plus 8 plus 16 plus 24 plus 4 plus 2 plus 16. I divide all that by 8. And I get an mean absolute deviation of 12.5. This basically means that this is the average distance all of these data values are from the mean. It's an average of 12.5. Now you should experiment, don't take my word for it, but consider this and test it yourself with some data values. The smaller the MAD, the closer the values are to the mean. The larger the MAD, the further the values are from the mean.